All right, so first we're going to review polynomial division. So dividing two polynomials, there's a couple ways you can do this. And so here's our first example, which would be good to have in your notes. X cubed minus 5x squared plus 4x minus 3, and we'll divide that by x minus 2. And so this, I think you saw last year, we're going to use synthetic division, usually written with an upside down sort of box like this. Up here go the coefficients of the numerator. And so I have 1x cubed minus 5x squared, 4x's, and minus 3. Main thing to watch out for here is you have to account for all the powers from your top one down to the constant. And so if there's ever something missing, like there are no x squareds, just make sure you include a 0 as sort of a placeholder. Out here is not this number, it's the number that makes the denominator 0. So what makes x minus 2 0? Positive 2. So sort of the opposite. Synthetic division only works when the thing you're dividing by is an x to the first power with a lead coefficient of 1. If you have a different number in front here, or you have a power up here that's not 1, synthetic division does not work, or at least would need some adjustments. So how do we proceed? For synthetic division, the first thing is just to bring the 1 down in front, and then it's a multiply and add process. So 2 times 1 is 2. That goes in this slot, and then you add. And so negative 5 plus 2 is negative 3, and then you repeat. So multiply, 2 times negative 3 is negative 6. Add negative 2, 2 times negative 2, negative 4, add, we get negative 7. And so the next thing we have to do is interpret the results. This last number is always the remainder. So it's nice when that remainder is 0, as we'll see in the next video, but sometimes the remainder is not, so that's the remainder. And then we work back up the chain. The last number is a plain constant. The next number is the coefficient of x. Next number is coefficient of x squared, and if need be, we would just keep going. This makes sense because we took a third-degree polynomial divided by a first-degree polynomial. Makes sense that we get a second-degree polynomial. And so the final answer here is x squared minus 3x minus 2. And not sure if you did this last year, but we can take that remainder and put it over what we are dividing by. Just sort of like when we're dividing with plain numbers, if we have a remainder of 3, we are dividing by 4, that's 3/4 or 0.75 left over. So this is the answer via synthetic division. Okay. We're going to do the same problem with the other method. The other method is Polydoku. We're sort of working backwards from a generic rectangle. So same problem, x cubed minus 5x squared plus 4x minus 3. So let me rewrite this so we can see it. We're going to divide by x minus 2, so x cubed divided by x minus 2. And so I'm going to set up a generic rectangle, and I know one of my factors is x minus 2. And basically, trying to figure out what goes across the top of the generic rectangle to make the inside boxes equal this numerator, right? So the numerator is sort of the answer. And so I know my upper left-hand corner has to be x cubed. And so that first term here goes in that upper corner. And now I just sort of work backwards. So if this is x cubed and this is x, what has to be here? Well, it has to be x squared, because this times this has to give me the x cubed. Once I know this, though, then I can fill in this box of the rectangle. So that's minus 2x squared. So let's think about this. I have minus 2x squareds. I'm supposed to have minus 5x squareds. And so that means I have minus 3x squareds left over. So these two together give me the minus 5x squared. But once I know that, then again, I can work with this box. That tells me that, oh, this has to be a minus 3x, right? Minus 3x times x would give me my minus 3x squared, just like I need it. But now I can do minus 3x times minus 2, and that will give me plus 6x. And what am I aiming for? I was aiming for 4x, and so this must have been minus 2x, because again, then these two together give me 4x. And so if this is minus 2x, then This x means I have to have a minus 2 here. These numbers should be looking familiar. Minus 2 times minus 2 is 4, and it's sort of like I'm done, but unfortunately these boxes don't give me minus 3 at the end like I need. And so what's hanging out here outside the box is minus 7, right? Because 4 minus 7 will give me the minus 3. And this thing that's outside the box is, of course, the remainder. And so, again, I end up with that same answer, x cubed minus 3x, x squared minus 3x minus 2, and then remainder of negative 7. And so we get that same answer in both situations. You can use whichever one you prefer, synthetic or polydoku. Polydoku works for anything in the denominator. And so we talked before about when synthetic division does not work. And so if synthetic division does not work because you have a power higher than 1 or you have a lead coefficient that's not 1, then you have to use polydoku. Thank you.